Hi, I'm Rob Amos. I'm the chief engineer at SCX.ai. I'm just going to take you through the demos that we presented at Sambahouse on Wednesday night. Our first presentation was on MiniMax versus Claude 2.5. So this is MiniMax from SCX.ai running on our hardware local in Sydney in Equinix S/5. So what this test is essentially an equivalent intelligence model comparison. So MiniMax is about the same relative intelligence in uh, and in knowledge of Claude Opus 4.5, so the previous flagship model from Anthropic. It's most commonly used for, well, both of these models are most commonly used for coding, but I'm just going to show you a quick demo of like what you can expect to achieve or what you can expect to see in terms of performance and efficiency from SCX.ai's inferencing hardware. So we've got here on our website at scx.ai/compare. You can go to this publicly and test it for yourself. So we've got a side-by-side comparison where you can prompt both models at the same time. And so we've got a test prompt here, just as an example to run a side-by-side comparison, and you can come in here and put in whatever prompt you like and test it out. So I'm just going to run this one right here. And you can see we've got a streaming comparison side by side. MiniMax is already complete, still waiting on Claude. The answers are pretty much exactly the same. And we can go down here and we can check out the performance characteristics of that request. So strangely enough, we can go through here and see time to first token. So unfortunately, Claude won there for a second, but we can run it again and we'll get different results with the different prompts. But throughput, so for MiniMax on SCX's hardware, we're getting 141.5 tokens per second. That's why it finished so quickly. We also got the total, because it's so fast, the responses finish much quicker. Cost, so these are real costs you can expect from SCX's platform. For the equivalent prompt rerun 1,000 times, you could expect to see a cost of 48 Australian cents. For Claude Opus 4.5, you would expect about a $12 or almost $13 bill. In terms of environmental impact of those queries, it's very important for us at SCX. We're very environmentally conscious of the AI future that we're creating. So we are running a very efficient ASIC-based hardware, which is considerably generations ahead of GPUs in terms of efficiency for inference-based tasks. They are only inference-based chips, so they don't do anything else other than inference. And so because they're so specialized in that one task, they can be optimized to the absolute maximum to produce the most efficient compute possible for that task. So what that means is for energy consumption and environmental friendliness, we are using about a quarter of the energy as compared to what you would expect for a GPU-based workload. And for water usage, the system is completely air-cooled. There is no water cooling involved. So even though that it is air-cooled, we have to measure in terms of water effective usage. So what that means is we convert the energy used to cool the system through conventional aircon into what it would be in water. So we have for that same sort of request that we just ran before, if we ran it 1,000 times, we would only use the equivalent of 89 milliliters. Where for the Opus 4.5 model, which is a GPU-based system predominantly using evaporative water cooling, you'd expect to use about almost 9 liters. And this is based off optimistic assumptions for their thing, and you can for their system, and you can come here and see how all of that's calculated, and we've got sources for how that is, what sort of metrics we use for those calculations and where to get them. So these are from the latest reports from Google and AWS on their environmental impacts of their GPU compute, and as well as a few other sources. So we can run another query just to show you that it is real. So you can see that the MiniMax is already complete. Pull down here with a full working example of Dijkstra's algorithm, a common optimal path finding algorithm. And we can see that the responses are almost identical, just a slightly variant in the tree construction that they used as their example, and both in Rust, which is a modern complex language. And we can see here on this request, because it was different, I think it's optimized for that previous request we've made several times, that the Claude is responding faster for it. So on the fresh request, we can see that our MiniMax is also faster to the first token. We're getting higher tokens per second because it's a larger query, so it gets more sample time. So 286 tokens per second. For typical workloads, you can see up to 399 tokens per second through MiniMax. For Claude Opus, that we're seeing 80 tokens a second, which is probably the fastest I've seen it in all my demos. And for everything else, it's roughly the same because the compute works out about the same. So yeah, that's the apples to apples comparison of MiniMax versus Claude Opus 4.5 on SCX.ai's hardware. Okay. The next thing I'm going to go through is what it's like coding with our coder model, which is a fine-tuned, optimized version of MiniMax through SCX.ai. Okay, so the preferred coding environment that we're using to use the coder model is OpenCode. So OpenCode is a open source IDE that we prefer to use as a harness to use the model. So I've got two examples to work through here. So we've got a completely sovereign coding environment set up where we use Coder to do the full development cycle. So this would be useful for people that need to or want to use AI in their coding workflows in regulated environments, or inherently concerned about all of the data that they're giving to Anthropic and OpenAI, and want to protect their IP going forward. So we'll go with the sovereign solution first, which is, and we'll just spin up a demo app. So we've got a config file that I'll share after this webinar, where you can copy and paste it into your next project, install OpenCode, and spin up this coding environment to test it out for yourself. So we can start by asking we'll build a simple HTML polling app. So we can see that SCX is it's already done, and we can go and head and switch to build mode and say, yes, build this. And we can see that because it's so fast, we can get through the workload so much quicker. And so when you extrapolate this to a real programming task, being able to generate code faster, 4 times faster than the latest flagship model, lets you get to the app faster, lets you get to testing faster, lets you get to iterating faster. So you're testing and then reevaluating, fixing what's wrong, and shipping about 4 times faster than you can with Opus 4.6 or 4.7. They're already done. We can open up that app. So I've got our polling app here, very basic. It's what I asked for, and we can pick our favorite language, and that's it, polling app done. So we can do the same. So we know that some people will always want to use the flagship models, and we understand that, and it makes sense in some scenarios to have that. So we also have a hybrid approach where we can have Opus 4.6, 4.7, or GPT 5.5 do the planning step of the process. So you saw there in that previous example, we did a planning step before we build the actual source code. So it's generally what you do with these coding environments is you do a plan, and then you get the agent to go through and execute that plan. So we can split those two processes between models. And so we can get, for example, a flagship model like Opus 4.7 to do the planning. So build out a really nice spec for the app. And then we can use SCX Coder to go through and build out the app in that very fast iterative loop. So if we go to hybrid, so in here, fire up open code again. Okay, so with this new example here, we can say when we switch to plan mode, we can see that the model tag is now Claude Opus 4.7. We've got extra high thinking. Now pulling out. So we've got Opus doing the planning for this app, and it's going to build out in a slow way. It's going to read the code base. It's going to do all of the things that Opus does to consume more tokens and charge you more money to go through and build out that plan. And then once it's done, still waiting. Once it's done, okay, there we go. Questions. So you can see using a frontier model, it will be more extensive in terms of the questions that it will think about, but it has burned through a lot more money and tokens that way. But so we've got just the same sort of answers. All right, let's go on. So we are still waiting for this planning step to finish, but we will soon switch over to our coder model, SCX's coder model. And we can see it's overthought and is using a single page app to build it instead of static HTML. That's fine. And so now we switched over to SCX Coder, and it's going to go through and execute the plan that it has built. And so we should have a drastically reduced cost, faster execution time. So we're getting the benefits of the faster token throughput to build the actual application, and still retaining the high thinking capabilities of Opus 4.7. And while that's going on, we can also see on the right-hand panel, we can track our usage and cost. So SCX Coder, being an open source model, has a context size of 196,000 input tokens, or token window, sorry. So that's your budget that you have in terms of input. Okay, we're done. And so you can configure open code to know that, and it can perform compactions as it goes on. So obviously you don't get the 1 million token context window that you have for Opus 4.7, but you don't particularly need it in terms of these modern coding environments because they know how to do compaction and those sorts of things. All right, let's open that up. So here's the app that was built by the hybrid model of Opus 4.7 and SCX Coder. So we can see it's a bit more involved. So with Opus doing the planning, we've got a much more detailed plan, perhaps overkill plan. So that demonstrates like what you can expect to achieve with a hybrid approach. So you sort of get the best of both worlds. So you reduce your exorbitant Anthropic bill by switching to a much more cheaper and more efficient implementation through SCX to do the actual programming, which is the most context-consuming sort of process, but retaining the intelligence of the frontier model to do the overall plan. All right. Great. I think that pretty much sums up the benefits of using SCX Coder and hopefully demonstrating why you might want to switch to a sovereign solution for your coding needs. And yeah, I think that's it. So if anyone's got any questions, happy to answer them right now. Yep, thanks, Sam. Yeah, can you use any other models in hybrid configuration? Yep, you definitely can. So you can use any combination of frontier model with any other model from SCX. So you can do any sort of comparing. So we offer other models that you might want to use in a coding workflow. So we offer Llama 4 for doing OCR, which is essentially a image processing model. So you can throw a screenshot, for example, if you wanted to clone a website or something like that, you could have Llama 4 in your stack from SCX do the essentially look at the image and create the description of the image for that description to then be passed to either Opus to do the plan, and then you could then get SCX Coder to build out that plan, or any combination of those sorts of things. So there's lots of capabilities that you can sort of mix and match together into OpenCode, as well as other harnesses. So OpenCode's not the only one we will work with. We work with lots of other harnesses, and yeah, there's all sorts of combinations you can do. Thanks, Alex. What sort of workloads do you think are best for this hybrid approach? The hybrid approach is pretty good for just everything. So it's very powerful, and you can use it for anything that isn't, if you're not super conscious of your code base being, well, depending on what sort of tier you're on in Anthropic, but you're not super conscious of your code going to Anthropic. So even though you have the planning in step there, it's going to scan your code base and upload that to Anthropic servers. But you can use it for everything. But if you're really looking for that full sovereign solution where nothing gets stored and you retain all your IP, you need to go with that full sovereign solution of using SCX Coder for the full stack of the build cycle. So yeah. All right, great. I think that's it. So I hope that's been a good coverage of SCX and using SCX Coder in conjunction and with Anthropic models, as well as how efficient and cheap the SCX Coder implementation is to switch, and how easy it is to switch, sorry. So yeah, that's great. All right, thank you all.